Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at GCE Practical June 2019 Group 1 Paper 3. So before we start looking at this paper, I want to remind you guys about the pre-registration for Concours classes, which has already started and it is ending on the 25th of May. For those of you guys who want to know more about this pre-registration, just read the information on your screen or search on this channel. You're going to see a video that is talking about the pre-registration and you understand better. For those of you who have heard about it and you're delaying to get to me, please make sure you get to me before the video, maybe at the end of this video. You get to me on WhatsApp and you pre-register yourself for the preparatory classes for the concours that will begin on the 10th of June in the northwest, the southwest, the center, the littoral and the west regions. So for more information about preparatory classes for concours, you can get to me directly. So let's get started. Okay, so most of the times I usually animate my videos, okay, but this time around I'm extremely tired, so there is no time to animate the videos. So basically I will every slide will just display with all the informations I have placed on it, and all I have to do is I have to explain. So make sure you listen keenly to what I am saying, because not everything I'm going to say is displayed on the screen. So make sure you listen very carefully to what I'm saying. If you have any question, you post your question in the comment section. I will reply instantly. Okay, all right, so the first section of physics paper 3 is mainstream, and this mainstream here is dealing with electricity. So mainstream 1, you are provided with a capacitor and a resistor. Write down the value of the resistance of the resistor. Explain how you got it. So you need to write down the resistance of the resistor and then you explain how you got the resistance of the resistor. Then next, the capacitance of the capacitor to determine the time constant of the capacitor. All right, let's begin with how do I find the resistance of the resistor. Generally, we can always measure the resistance of the resistor using the multimeter. Okay, but this time around, according to the question, we were not provided with a multimeter at the onset. Though when you continue reading the question, you realize that the multimeter was now brought in. But for question number 1, you are provided just with the capacitor and the resistor. So to get the resistance of the resistor, you cannot use the multimeter to measure. You have to use what we call the resistor color code. Now this resistor color code is saying that if it is a 4-band capacitor resistor, which means that there are 4 colors, okay, the first color is the first digit of the resistance, the second color is the second digit of the resistance, the third color is the multiplier, and the fourth color is the tolerance. Now this fourth color is always further away from these 3 colors. Okay, so if for example the first color is, in fact I don't know these colors here, so I cannot use these colors. All right, I cannot use them because I don't know them. I am colorblind. Now if my first color is red, okay, now you need to know this chart in your mind. All right, you need to know the way the colors appear: black, brown, red, orange, yellow, green, blue, violet, gray, and white. And then for the tolerance, we have silver, gold, and then none. None is not indicated, which means if there is no color, the tolerance is plus or minus 20%. Anyways, if my first color is brown and my second color is orange, okay, and my third color is green, okay, so my resistance will be first color is brown, so I have 1, the first digit will be 1. If the second color is orange, the second digit will be 3, so you have 13 already. Then when you're going to the third color, you are multiplying with 10 raised to the power something. So for the multiplier, if it is black, you multiply with 10 to the power 0, which is 1. If it's brown, 10 to the power 1, which is 10. If it's red, 10 to the power 2. So you're just multiplying with 10 raised to the power the number of the color. Okay, so let's just say, okay, the first color is brown, second is red, and third is orange. So my resistance will be first color brown, the first digit will be 1, second color red, the second digit will be 2, third color orange, that's a multiplier, so I'll multiply by 1000 ohms, or by 10 raised to the power 3 ohms. Now if the fourth color is now maybe silver, then I'll need to add and subtract. I would need to take plus or minus 10% of my resistance. So my resistance itself is, like we said, 112 times 1000, which is 12,000 ohms. Okay, 12,000 ohms, or 12 kilo ohms. Then plus or minus 10% of the 12 kilo ohms, provided the last guy here was silver. If it is gold, then it's plus or minus 5%. If there is nothing there, then it's plus or minus 20%. Okay, but you have to know that the resistance of this resistor, we don't take into consideration the tolerance. Okay, we take into consideration just the first theory. So the resistance will basically be, like I said, if it's brown, red, orange, is going to be 12,000 ohms, or 12 kilo ohms. That's going to be the resistance. So for you guys who know how to look for these colors, please tell me the resistance of this particular resistor in the comment section. Okay, which color is this? Which color? I know that this is red, but man, I don't know this color. I don't know this color. What's this? Maybe it is no, let not disgrace myself. Anyways, it's not my fault to be colorblind. Okay, all right, it's just overuse of light. Producing videos for you at midnight. I'm producing this video right now like this. The time, let me see the time. The time is 12:35. That's when I'm producing the video to upload still this period and send to you. So for you guys who know who have master colors, look at these colors here, use this chart and tell me the resistance of this resistor in the comment section. All right, next, so basically you need to write the resistance, and then you explain using this, that you use the resistance color code. All right, and then you got it. The capacitance of a capacitor. Now a capacitor is a device that stores charge. All right, the capacitance of a capacitor cannot be calculated, but in this case we don't even need to calculate it. All right, it's clear, it is read on it directly. So this capacitor here, for example, would have written there 3300 microfarads. So that will be the capacitance you're going to write. Now when you see this 25 volts, this 25 volt just means that that's the maximum voltage you can store. Okay, but we are interested in the capacitance. So the capacitance, you just read it directly on it, 3300 microfarads. Now let's talk more about this capacitor. A capacitor has two terminals. The shorter terminal is the negative, while the longer terminal is a positive. Okay, so, or if you don't want to remember that way, for you to get a negative, just come to the terminal where you see this white portion there, and there are these little boxes. All right, these horizontal little boxes, they stand for negative. So the short terminal is a negative, while the long terminal is a positive. This resistor has all the terminals have same polarity. There's not like negative and positive, they're just a loads. Okay, so the capacitance of the capacitor is basically read on the capacitor. Okay, determine the time constant of the capacitor. So first question I'll ask you is, what is the definition of time constant? Tell me your answer in the comment section. Okay, but anyway, the time constant is just R times C. That is the resistance of the resistor times the capacitance of the capacitor. So you just need to multiply the two previous values, you get a time constant. Now let's talk about this multimeter. A multimeter is a device that is used both as an ammeter and a voltmeter. So it measures many things. So it measures resistance, it measures current, and it measures voltage. So when you look at a multimeter, okay, if you want to measure the resistance, you need to, you see this is a pointer, this is the head of the pointer. If you want to measure resistance, you go to where the ohm is. Can I even see it here? Okay, here is the ohm section. This section that is in I don't know, colorblind person. In fact, I think this is green here. Yeah, I'm sure it's green. Is it green or is blue? In fact, this portion like this, yes, this portion like this is a portion of the resist, of where if you want to calculate the resistance, you take your two wires of the multimeter and connect to the resistor, to the wires of the resistor, and then you turn your pointer to face the resistance section, and then you read your value. Okay, now if you want to calculate the voltage, you need to turn it to face the voltage section. If you want to calculate the current, you need to turn it to face the current section. So that's just a work of the multimeter. Okay, so if there is any question, make sure you indicate in the comment section. So let's proceed. All right, like I said, I'm very tired. I could not animate it, so everything comes the way I just set up the PowerPoint. So follow me as I explain. Connect the positive terminal of the capacitor to the resistor. Using crocodile clips, connect the voltmeter across the resistor. Then connect the other end of the resistor to the negative terminal of the capacitor. Start the stopwatch immediately. Measure the potential difference V across the resistor every 30 seconds. Okay, so I consider two possibilities, group 1 and group 2. Okay, now so we are going to first of all analyze based on this information. Then I will now give you another set of information and we analyze based on that set of information. Okay, all right, now what are we doing here? We connect the positive terminal of the capacitor to the resistor. So here is my capacitor. Okay, here is my capacitor, here's my resistor. So I first of all connect. All right, here's a connection first of all. Then later, what do? I use crocodile clips and I connect the voltmeter across the resistor. So here's my voltmeter connected across my resistor. Then I connect the other end of the resistor to the negative terminal of the capacitor. So here's the other end of the resistor. I connect to the negative terminal of the capacitor. So this process is what we call discharging a capacitor. All right, so this capacitor is fully charged. It has a certain charge on it, and then now we can discharge it using the resistor, where we are going to be measuring the voltage drop across the resistor. So we need to discharge this capacitor, and here is a relationship. The voltage is equal to the initial voltage times e raised to the power negative t divided by RC. This voltage is a voltage at a certain time t. This initial voltage is the initial voltage of the capacitor, all right, and then RC is a time constant, where basically R is a resistance of the resistor and C is a capacitance of the capacitor. But in another case, that is for group 2. For group 2, they were instead charging the capacitor, where rather they had a battery. Okay, so they have a battery, and then we do the connection, but in this space here we need to connect the battery. So the capacitor had 0 volts, and then now it was now being charged. So that is it, and here's a relationship. Now there are two formulae here. The voltage of the resistor is equal to the voltage of the battery times e to the negative t on ROC, or the voltage of the capacitor is equal to the voltage of the battery times 1 minus e to the negative t on ROC. So any of them is going to work depending on what you're asked to plot. All right, but in this question we are concerned with the first case. Now the fourth thing is we need to table of values. So we have voltage in volts and we have time in seconds. So maybe I just created some values of the voltage. Since you are discharging, the voltage is going to be decreasing. Now the time was to be recorded after every 30 seconds. So the precision of the stopwatch most at times will be 0.01 seconds. So you need to put all the answers to decimal places. But you always have to check the precision of your stopwatch. Okay, so we have 0.00 seconds, 30.00 seconds, 60.00 seconds, right up till maybe a certain value that you want, maybe after having 8 or 9 values on your table. Now according to the next question, we need to plot the graph of ln V on the vertical axis against T on the horizontal axis. So you go to the table again and then you add a column of ln V. So you take the ln of every value of V and your result is still in volts. Okay, so in the first case, all right, though this is a graph we are drawing, but let me just analyze using the first case. Since our main concern here is discharging the capacitor, the initial voltage of the capacitor is the voltage that it is having, which is V0, okay, that is at time equal to t0. Now according to the formula, the voltage decreases exponentially with time, so that's it, is decreasing exponentially with time. Okay, so if I'm plotting a graph of V against T, this graph is going to begin with V from V0 and then it's going to decrease exponentially with time. But anyways, that's not our major concern. Our major concern is plotting the graph of ln V against time. You realize that if you linearize this equation, though this equation is not given to you in the whole, but you need to have the idea of the theoretical part of these concepts. So if you linearize this equation, what are you going to have? Ln V equal to negative t on ROC plus ln V0. So if you plot the graph of ln V against t, the slope is basically negative 1 all over ROC and the intercept is ln V0, that is when time is equal to 0, and it has a negative slope. That's why the orientation of the graph is like this. So if you're asked to find the slope, you need to find the slope of this line, okay, and finding the slope of this line is basically the slope. Normally you choose any 2 points on the line and then you find the slope. Now to check if your answer is correct, we know basically that the slope from this linearization is negative 1 divided by ROC. Alright, so what is ROC? Negative 1 divided by slope. But we know that ROC is also the time constant, so the time constant is negative 1 divided by the slope. The slope will be negative, so the two negatives will cancel. Now when you punch everything here, you now compare with your time constant that you calculated at the beginning of the equation to compare your two values. Okay, now let's go to the stations. Station 1, properties of matter. A certain storage container has a volume of 1.2 meter cube. You are provided with a liquid labeled N in a cup, a measuring cylinder, and a balance. Determine the density of this liquid and use this information to determine the mass of the liquid required to fill the storage container. For the calculations, so I'm just going to be more concerned here with the calculations, okay, because I think the diagram and all those things, if you're preparing for physics by now, you should know how to be drawing all those things. So I'm more concerned with the calculations and how we analyze such questions. So first of all, we have a balance. So the mass of the liquid is the mass of the cup and the liquid minus the mass of the cup. So first of all, since the liquid is in a cup, you carry the content, that's a cup containing the liquid, and you place on the balance. You're going to have the mass of the cup and the liquid. You now carry the liquid, you pour into the measuring cylinder, and then you measure just the mass of the cup itself. Alright, so the mass of the liquid will be the difference between the mass of the cup and liquid and the mass of the cup. Now when you pour that liquid into the measuring cylinder, you measure the volume of the liquid, which is V1. So the density of the liquid is the mass of the liquid divided by its volume. You get the value of the density. The density of the liquid is unique. Okay, you are asked to do two things. You are asked to find the density of the liquid, and then you now determine the mass of the liquid required to fill a certain storage container, and this storage container has a volume of 1.2 meter cube. So the density of the liquid is constant, which means that since density is mass on volume, it means that the first mass on the first volume is the same as the second mass on the second volume. Okay, so from there you can make the second mass a subject. So the second volume is 1.2 meter cube because it is the volume of the storage container. So the second mass will be 1.2 times the first mass divided by the first volume. So that gives you the mass that will be required to fill 1.2 meter cube storage container after finding the density of the liquid. Now let's go to simple harmonic motion. Determine the period of oscillation of a simple pendulum bulb using the material provided. So we have a bulb, we have a string, we have a stopwatch, we have a clamp and stand. Yes, that is it. And we need to determine the period of oscillation. So listen. So here we have the simple pendulum bulb. To get the period, we have to oscillate it for a certain number of oscillations, and then we find the time taken using the stopwatch. So once I release the pendulum bulb, I will start my stopwatch. So all we need to do is we basically do this. 4, 5, 6, 7, 8, 9, 10. Alright.
So the time taken for 10 oscillations according to my stopwatch is 10 seconds. So basically I can now get the period by taking 10 seconds divided by 10 oscillations. So the period of this simple pendulum is 1 second.
Alright, so basically what I was explaining here was that we just have to oscillate. Okay, the clamp and stand is already having everything in set, so we just have to release it from the vertical position, and then we try to shift it from its equilibrium position. We put it around this position, and then now we release, and then period is time taken over number of oscillations. So you start the stopwatch as soon as you release, and the time taken to move from the position here to this position and back to this position is 1 oscillation. That's a period. But for us to have a good value, we can do like 10 oscillations, and we calculate the time taken, then we divide, we get a period, and that is it. As easy as that.
So here we have the simple.
Okay, now please don't laugh at my things. Let's go to station 3 optics. You are provided with a plane mirror in its holder. The holder is my hand, don't bother. A white sheet of paper, a 30cm ruler, 4 optical pins, and a protractor. Investigate the relationship between the angle of incidence and the angle of reflection of a ray of light incident on a plane mirror. So basically, forget about this diagram. Let's come to what is happening. So you draw a horizontal line where you're going to place a mirror and a holder there. All right, you now draw the normal, which is this vertical dotted line here, as you see. Now next, you choose any angle of incidence you want. Maybe you measure 30 degrees. That's from the normal. You measure 30 degrees, you put a dot, and then now you draw a line linking the point of incidence and then the dot. All right, and then you write the angle. This is 30 degrees. You do that using a protractor. Now your mirror is there already. You now place these 2 pins here. All right, you place these 2 pins. When you place these 2 pins, you realize that the images of these 2 pins are seen in a mirror, and these are the images. Now how do I get a reflected ray? You basically take the other 2 remaining pins, and then you try to place them on this section of the paper, so that these 4 pins, so that the 2 pins inside here and the other 2 pins are on the same line. Okay, that's all you have to do. When you do that, you can now remove the mirror, and then you measure this other angle. Because this is the reflected ray. So reflection is a bouncing back of light, and there are 2 laws of reflection. The first law is that the angle of incidence, which is 30 degrees, must be equal to the angle of reflection, so it must be 30 degrees still after when you measure. The next law is that at the point of incidence, here's the point of incidence, the incident ray, the reflected ray, and the normal, the incident ray, the reflected ray, and the normal all lie on the same plane. You see, they are on the same plane, they are on the same section of this paper. So basically that's what you have to do. So you can try to carry out in your house. Okay, you have a plane mirror, just use a protractor, and you see if it's going to give you the same value. Okay, so this was how I drew it. You have an incident here. I measure my 30 degrees. I put pin 1, pin 2. Then I try to locate the other, to locate the images and make sure that they're on a straight line. I put pin 3, pin 4. Then I make sure that this angle is also 30. In fact, you're measuring to show that the angle is 30 degrees. So that's the relationship between the angle of incidence and the angle of reflection. They are always the same. All right, since it is a plane mirror and you're undergoing reflection of light. And like I said, reflection is a bouncing back of light as it meets a smooth surface. If it was refraction, it will be the bending of light, and in that case we see we see kind of glass prisms, right? They deviate light. So I think that's all I had for you guys. I wish you guys all the best. Any question in the comment section. Thank you once more. Make sure you share this video with your friends. Okay, thank you.